In this video, we will derive the half-angle identities for cosine and for sine, and we will make use of the double angle identities to derive these two. Starting with the double angle for cosine, cosine of 2x equals 2 cosine squared x minus 1. If we take this identity and on the right-hand side, isolate the cosine x, we can start that by adding 1 to each side. And then we can divide by 2. Isolating cosine squared. Taking the square root of each side. I'm not forgetting the plus or minus. This isolates cosine x on one side. So we can rewrite this as cosine x equals plus or minus square root of 1 plus cosine 2x over 2. Now make use of these angles here. Take a look at the angle. We have angle x, and it becomes a form with the angle 2x, which is twice whatever that angle is. So I'm going to do a substitution here. Let's pretend that an angle theta over 2 is equal to this x. What we're going to do is let x equal theta over 2 so that we can rewrite this as a half angle form. Let's rewrite this as cosine of, in place of x, we can write the angle theta over 2, which is a half angle form. And this will be equal to the plus or minus square root of 1 plus cosine of twice that angle. So twice the angle theta over 2 is theta. Or you could think of it as multiplying 2 on each side, theta will give us 2x. So let's substitute 2x as theta and finish this form as all over 2 inside the square root. So here we have the half angle formula for cosine. Cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta, which is double whatever that original angle theta over 2 was, over 2. Let's try the same thing over here for the cosine of the double angle form in terms of sine, though. So this will allow us to isolate sine if we use this version of the double angle for cosine. Let's start by subtracting 1 from each side. We want to isolate the sine term. We can divide by -2. So dividing by 2, I'm going to write the cosine term as the negative, the -1 term as positive, keeping it over 2. So I took that negative and distributed it into the numerator. And we still have sine squared. Square rooting each side, don't forget plus or minus. We can rewrite this as sine x equals the plus or minus square root of 1 minus cosine 2x over 2. And doing the same substitution as the previous one, because the angle x becomes a double version of that angle over here, we can let theta over 2 equal x so that we can do a substitution as our final result. Instead of writing it as sine over x, or sine of x, we can write this as sine of theta over 2, so that on the right-hand side, we will have an angle that is double of that theta over 2, which will be angle theta. So here we derive the double angle, half angle for sine. Sine of a half angle equals plus or minus the square root of 1 minus cosine of that angle doubled all over 2.